Hi, welcome to 371 Souls Lab videos. My name is Sutton Norris and will provide you a brief description and purpose for these labs. So for the CE371 labs, we're going to be operating as a geotechnical consulting firm that will provide geotechnical services for a project that will connect West Point to the Garrison train station via a small diameter tunnel underneath the Hudson. In order to do that, we need to perform a variety of tests. For lab number one, we're going to do the unit weight determination, the moisture content determination, a visual analysis, and the jar test. So let's get started. Before we get started, we'd like to do a quick introduction onto the materials that we'll be using for this lab. First, we have our Proctor mold right here. This portion right here is our top collar, right here, top collar, main portion, base. And these guys right here on the outside, these are your wing nuts, used for tightening and loosening. Inside the mold, we have soil. It's not dirt, it's soil. Second up, we have our tear cans. These guys right here will be labeled by a number and then a letter. So we're at station 5, so that's why there's a 5 right here. The lid and the can will have matching numbers. You want to make sure these are matching, and you record your group's numbers and letters. So that way, when you get the information back, you won't be scrambling. You know what exactly what tear cans you're using. Second up, we have our jar. This will be used for putting stuff inside for a visual analysis or the jar test. And then here's a wax pen that will be used to mark the outside of the jar. We have our number 4 sieve right here. This 5 right here just means that it's from station 5. This number right here, this is your number 4 sieve. So you want to make sure that this number has number 4 there. Next up, we have our dog bowl. Go dogs. We have our large pan. We have our small scale. And then our large scale. And then for manipulating the soil when we're breaking it apart and getting samples from the inside, we have our steel bar right here, used to help break it up, smash the soil up, be able to get good samples from the inside. We have our ice pick, used for breaking apart the sample because it will be very compacted. And then when we're transporting soils, we have our teaspoon right here. And then we have our soil scoop. Probably also be used for ice cream as well. And finally, we have our brush. Now when you are taking out the soil from something, let's say like the mold, you want to brush all the soil off. So when you record the weight of whatever piece of equipment you're using, you make sure all the soil's out there. You get the actual weight of the equipment, not the weight of the equipment plus a little bit of soil on there. And that is the equipment we'll be using for this lab. So the first field test we're going to do is the unit weight determination. In order to do that, our first step is we're going to weigh the soil within the mold on the large scale. Note, before you weigh it on the large scale, you need to remove the collar. Top collar is removed and replace it here to the side. Now what we're weighing is we're weighing the soil, the main portion of the mold, and then the base plate. So now we're going to transfer this over to our scale, and we're going to read the bottom number in pounds. Note, right here, when you're recording the weight, you're going to put right here the weight that the scale gives you in pounds. It's the bottom number, not the top large number in grams. Also, the volume of the cylinder is going to be 1/30th of a cubic foot. I apologize for my handwriting. But again, you're going to do 1/30th of a cubic foot. And then the weight of the container, or the scale gives you right here on the bottom. The second step we're going to do is we're going to remove the soil from the mold. Note, we want to loosen these bottom wing nuts, twist the mold, and remove it. Now, if you're having issues with the mold, with the soil coming out of the mold, talk to your lab technician. And we're just going to remove this right here. So now that we've had the majority of the soil removed from the mold, What we're going to do is we're just going to make sure that we are getting these last little remnants of the soil with the brush. Make sure all that stuff's getting out. Because again, we want to weigh the actual mold. We don't want to weigh the mold plus these smaller particles. So make sure to get all that stuff out. And also make sure to get the inside of the mold as well. So for the third step, we're going to reassemble the mold and weigh the empty mold. Notice we are leaving the top collar off to the side and we are not weighing that. So to reassemble the mold, we're going to take the main portion, we're going to slip it on here, twist so it's locked in there, and just tighten down those wing nuts. And once these have been tightened down, you have assembled the main portion and the base together, and it's empty. And we're going to weigh that on the bar scale. Once it spits out the magic number, again, make sure to read the bottom number right here in pounds. We're going over here, and we're going to record the weight of the container. So the fourth and final step in the unit weight determination field test is we're going to subtract the weight of the container, which is the mold, from the weight of the wet soil plus the container. Remember, that's when we weigh the wet soil, all the soil together within the container. So when we subtract these two, we get the weight of the wet soil. And once we have the weight of the wet soil, we can now use the 1/30th of the cubic foot, which is the volume of the container, and we're going to divide the weight of the wet soil by that in order to get the wet unit weight right here. Boom.
Our next test is going to be the moisture content determination test. First thing we're going to do is record the weight of the tears with the lid on them using the small scale. And we'll put that information on our data sheet. And then after we have that weight, we will take the tears and put 2 to 3 spoonfuls of soil in it. And we'll record the weight of the tear cans with the lid on them as well using the small scale. To receive the weight of the tear and the dry soil, your lab technicians are going to bake these for 24 hours to get all the moisture out of them. So when you put the lid on it, make sure the lid matches the bottom of the tear can and just leave it cracked open so it'll let the moisture escape the tear. Place these in the bins designated by your lab technicians. So to bake this, it'll take about 24 hours, and then your instructor is going to email you out the weight of the tear and the dry soil, which is the next thing on our list. Once you have that weight, doing some maths, you can determine the rest of the information you need. To get the weight of the dry soil, you're going to take the weight of the tear in the dry soil minus the tear. To get the weight of the water, you're going to take the weight of the tear in the wet soil minus the dry soil and minus the tear. And then to get the water content, you're going to take the weight of your water divided by your weight of your dry soil and multiply it by 100. And note that all these weights are going to be taken in grams instead of pounds. Our next test is going to be the visual analysis and soil description test. In this test, we're going to take the soil that we've been using for this lab, and we're going to separate it into 2 different piles, one of fines and sands and one of gravel. And we're going to do that using the number 4 sieve. All right, to begin this, we're going to take the soil given to us and run it through the number 4 sieve. Once you get in there, you're going to try and shake it some to get everything that will pass through it to pass through it. And anything that does not pass through the sieve is considered gravel. So you're going to put that in a separate pile. You can see after I turn it upside down, there's still some rocks stuck in there. So you're not going to push those through. You're going to flip it over and use a wire brush to get those rocks out of there. And then you're going to repeat this process until you have all the soil from your dog bowl into 2 separate piles. From there, you're going to estimate the percentage of gravel in your soil sample, and then you're going to complete the soil description on your data sheets, and using table 4.2 of your textbook, you're going to begin to classify the soil.
The next test we're going to be conducting is called the jar test. The jar test compares the proportions of sands and fines within a soil sample. So we're going to take some soil that passed through the number 4 sieve and fill the jar up approximately 1/3 of the way. We're then going to mark that initial level with the wax pen. So that way we understand where our total amount is. Next, we're going to fill the rest of the jar up all the way to the shoulder with distilled water. Now we have to shake the jar for approximately 60 seconds.
I am now.
Alright, so now that we've shaken it for 60 seconds, we can assume that all of the sands and fines are suspended. We'll wait for 30 seconds, which will then allow us for all the sands to settle, and we'll mark below our initial mark the new level, which allows us to compare the amount of fines to sand in the soil. So if the large mark is 100%, the smaller mark is your percent of sand. So I approximate the soil to have 60% sand within the fine portion. By result, that means that there are 40% fines within this sample. And this is both passing through the number 4 sieve. The next test we're going to be conducting is the taste test. So, when soil engineers used to have to go and conduct field tests, the most sensitive part of the human body is the tongue. So you're going to have one lab member per group get up and take a sip of the soil. You want to move it around over your tongue, and that can actually give you a very good insight into what the soil is like, because the human tongue is sensitive enough to discern the difference between fines and sands, which the human eye is not always able to do. Thank you for your time.
Thank you for your service.